Hello class, today's lesson is 4-6 in your textbook about how to prove triangles that are congruent by ASA and also AAS. So two new things. Postulate 21 is talking about ASA, which stands for angle, side, angle. Okay, you're going to get these memorized very quickly. And what it says is if two angles and the included side, so now it's talking about the side in between the two angles, of one triangle are congruent to two angles and the included side of another triangle, then the two triangles are congruent. I have enough to prove that they're congruent. So talking in these two diagrams, really if angle A is congruent to angle D, and if AC is congruent to DF, this is the included sides, and if angle C is congruent to angle F, then I have enough to prove that triangle ABC is congruent to triangle DEF. Okay, so this is ASA, angle, side, angle. The second one that we're going to talk about is theorem 4.6, and it's very similar. Maybe I'll lower that a little bit so we can have both of them. And what it says is angle, angle, side. That's what AAS stands for. So two angles and then a side. So it says if two angles and a non-included side, this means the side is not in between those two angles. It can be on the outside. If those in one triangle are congruent to two angles and the corresponding non-included side of another triangle, then the two triangles are congruent, which means, for instance, if this angle T is the one that is next to the side, then its corresponding angle must be matching that corresponding side, okay? So in this diagram, what I would need to prove that these two triangles are congruent is that if I can find that angle R is congruent to angle U, and also if angle T is congruent to angle W, and if the side ST is congruent to the corresponding non-included side VW, then I have enough to prove that triangle RST is congruent to triangle UVW. Okay, so now I have ASA and AAS to add to my list of different ways to prove triangles are congruent. So why don't we just go over all of those different postulates and theorems right now. So the first one that we talked about was side, side, side. That's what SSS stands for. And so in our diagram, we were able to show that if one side matches to another, and a second side matches to a second side of a different triangle, and the third sides match, and they're all congruent like that, then I can say that because all three sides are congruent to the three sides of the opposite triangle, then I can prove that both triangles are congruent to one another. The second one that we talked about was SAS. That stands for side, angle, side. So I had one side. I also had an angle that matched, and I had a second side. Side, angle, side. So if I could show that two sides and the included angle, if those are congruent, then the two triangles themselves were congruent. Let's move on to the third one that we talked about. This was specific for right triangles. It stood for, HL stood for the hypotenuse leg. Okay, and so in my diagram, they were both right triangles, and if I could show that the hypotenuses were congruent and one of the legs were congruent, then the two triangles themselves were congruent. So the hypotenuse and one leg are congruent. This is for right triangles. Okay, and then let's just add to this list. So this is kind of like our cheat sheet, the ones that we learned today. So we just learned ASA, which stood for angle, side, angle. So I would have an angle, a side, and then another angle. That side is the included side. So two angles and the included side are congruent. If I could show this, then I could show that the two triangles themselves were congruent. And then the last one was AAS. So I have an angle, I have a second angle, and then I had a side that was not in between those two angles. We said that it was not included. So two angles and the same non-included side are congruent. That's what I'm looking for. So there are so many different ways now to really be able to show that two triangles are congruent to each other. The one that we talked about that showed that it was impossible for those to always be congruent was SSA, which backwards is ASS. And this is one you're just going to have to remember. It's not going to be possible, okay? So this is on our naughty list, kind of things that will not show that two triangles are congruent. And another one that I want us to think about is AAA. We haven't talked about if all three of the angles are congruent. And it would seem like, okay, if they're all congruent, that means that they're all 60 degrees. But looking here, all four of these different triangle examples that I drew are 60 degrees. And it's kind of clear and obvious to see that none of them are congruent. So we're going to say that AAA is also on our naughty list. So both of these I never want to see you try to use as proof for two triangles being congruent. So to wrap up, I just have three little diagrams for you. And in these diagrams, I want to see if you can prove if they are congruent. And if so, I want you to state the postulate or theorem. So here's the three diagrams for you. So go ahead and copy those in your notebook and just say yes or no. And if so, then say, oh, by side, 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 or side, angle, side, whatever it is. And I'll see you when you come back to class.